Welcome to today's episode. We're jumping straight into something really crucial for anyone who drives or, gets their car repaired, ADS calibration.
That's right, advanced driver assistance systems, all those high-tech safety features in newer cars.
Exactly. And after a collision, obviously, but even after something like a new windshield or maybe just different tires, these systems often need, well, a really precise tune-up.
They absolutely do.
Yeah, well, let's get into it.
One, two, three, four.
Welcome to Shop Talk, the podcast where auto repair pros get real insights to grow smarter, run smoother, and boost profits.
So our mission today is pretty simple, really. We want to give you the essential understanding of why this calibration matters so much.
Yeah, and we've pulled together some really good sources for this. We'll be looking at a discussion from the folks at IPAR, the training and repair experts. They give us the inside track on processes, training, and importantly, where things can go wrong. Then there's a technical piece from Motor Age, and that focuses specifically on calibrating ADAS on heavy-duty vehicles, bigger trucks and the like.
Right? Different challenges there, I imagine.
Definitely. And to round it out, we've got an equipment-focused article from Snap-on, looking at the tools, the technology that's involved.
So a good mix of perspectives then. Training, the actual repair process, the equipment needed.
Exactly, from the big picture down to the nuts and bolts.
Right? And look, we're not trying to turn you into an ADS technician here.
No, not at all.
But we do want you to be, well, informed. We'll break down why getting this calibration right is so important, what the risks are if it's botched, and, the key things that ensure accuracy and ultimately your safety.
Just the need-to-know stuff.
Exactly. No confusing jargon, just the info you need. Okay, so, the first thing that pops into my head is how do you even know if your car has these ADS features that might need this kind of calibration? Where do you start?
Yeah, good question. That's the logical place to begin. The iCar experts pointed out your owner's manual. That's your first stop.
Okay, the glove box, clicking sound.
Right. It should list the safety features your car came with, how they're supposed to work, that sort of thing.
Makes sense.
But for a deeper dive, you'd look at the OEM service information. That's the official repair guides from the manufacturer. Much more detail in there.
And they mentioned a resource, didn't they? RTS, a website or an app.
Ah, yes. Repair-Driven News, RTS. It's a fantastic free tool, actually, mostly used by repair shops.
Okay.
You put in the year, make, model of a car, and it tells you, okay, which ADAS systems might be on this vehicle, what calibrations could be needed after certain repairs, and even like the specific tools required.
Wow, that sounds really useful, like a quick cheat sheet.
Kinda, yeah. Gives you a good overview of the ADAS situation for that specific car.
So it's clearly not just after a big smash-up that calibration might be needed. You mentioned even seemingly small jobs.
That's a really critical point the iCar folks stress, this idea of cause and effect in any repair.
Okay.
You've got to think, okay, I'm just taking off this bumper cover to repaint it. Seems simple. But are there any sensors mounted to that cover? Radar, cameras?
Right. Maybe parking sensors or something more complex.
Yeah. Exactly. If you detach or move them even slightly, they'll almost certainly need recalibrating when you put it all back together. You have to think a step ahead.
They actually laid out a kind of four-step process for repairs, didn't they? Which seems useful for anyone trying to get their head around this.
Yeah, they broke it down nicely. First, identify. Find all the ADAS bits on that specific car using its build data like its factory birth certificate.
Okay, know what you're dealing with.
Second, determine. Figure out which repairs you're planning might actually affect those systems. Third, research. Look up the exact calibration procedures. Not just the calibration itself, but also, crucially, how the vehicle needs to be prepped beforehand.
Ah, vehicle prep. That sounds important.
It's step 4, and it's vital. Recognizing that getting the vehicle ready, things like, is the trunk empty? Are the tires inflated correctly? Are the fluid levels right? All that is just as critical as the calibration procedure itself.
Like a checklist before surgery.
Pretty much. Each step is essential for safety. Skipping one, that's potentially compromising how the systems work.
That vehicle prep part? What? The fuel level example they gave really stuck with me. Can you remind us about that? It highlights the sensitivity.
Oh, yeah, that was fascinating. It shows how tiny changes mess things up. They talked about the weight difference between a full gas tank and maybe a quarter tank.
Okay.
That tiny difference could change the vehicle's actual angle, like how it sits, by maybe 1 degree.
1 degree. Doesn't sound like much.
Doesn't, right. But think about pointing a laser. A tiny wiggle at your end means the dot moves a lot further away.
Ah, okay.
Same with the VAS sensors. That 1 degree off angle close up, it means the sensor's looking way off target down the road. Big aiming error.
Wow. And they contrasted that with factories, right? Where it's all automated.
Yeah, highly controlled factory lines don't have these manual prep issues. Everything's precise from the start.
Okay, that really paints a picture of the precision needed.
Yeah.
So the Snap-on article, what did it list as common times when ADAS calibration is like a definite requirement?
Snap-on gave a good list, obviously after collision repair, that's number 1. But also replacing a bumper, putting in a new windshield, lots of sensors there, replacing the actual sensor or camera itself, any suspension work.
Suspension, why that?
Because it changes how the car sits, its ride height, its angles.
Okay.
Also changing tire size, that affects things too. And interestingly, even after a wheel alignment.
Really? Yeah,
After an
because
alignment.
an alignment can change the vehicle's thrust angle. Think of that as the direction the rear wheels are pushing the car. If that's off even slightly, everything built on that, like the forward-facing cameras, can be misaligned.
Okay, so we're getting a clearer picture of when calibration is needed. But what about the flip side? What if it's just not done right or maybe skipped entirely? What are the actual dangers?
This is where it gets pretty serious. The ICAR experts were really strong on warning against these remote or parking lot calibrations, because he's asked for that sometimes, right? Mobile calibrations.
You do, but the core problem is the environment. It's just not controlled. No matter what they claim about success, it's incredibly hard, maybe impossible, to get accurate results outside a proper shop setup that meets the manufacturer's specs.
And they made a point about how the ADS systems themselves kind of trust the setup. Can you explain that?
Yeah, it's interesting. These systems are smart, but they operate on trust. They assume the preconditions are met.
Beating.
Meaning, if the cameras or sensors can see the calibration targets, the system will just go ahead and calibrate based on what it sees.
Even if the car's parked crooked or the targets are in the wrong place.
Exactly. It's like, imagine your GPS thinking a blurry photo of a map is accurate. It'll plot a course based on bad data. ADS does the same. It calibrates to what it perceives, even if the perception, the setup, is totally wrong.
And you wouldn't necessarily know. No warning light.
Not immediately, no. The system thinks it's calibrated correctly, but it's actually misaligned. That's the scary part. It could fail when you need it most.
Wow. Okay, so that rules out dodgy parking lot jobs. What about finding guides online like DIY calibration on YouTube?
Oh, definitely avoid that. The iCar team was very clear.
I do.
Random YouTube videos are not credible sources for this stuff.
No YouTube certified technicians.
Precisely. You absolutely have to stick to trusted sources. That means the official OEM procedures from the car maker and reputable bodies like iCar, they base their info on actual engineering and testing.
Okay, so a controlled environment is non-negotiable. Let's dig into that. What makes a proper calibration bay, especially for static calibration where the card isn't moving?
The level of detail is pretty intense. First off, a floor. It has to be perfectly flat and level.
Which isn't always the case in a workshop, right? Drainage slope.
Exactly. That's a common hurdle iCar mentioned. Many shop floors are slightly sloped. Then there's lighting. Specific conditions are needed. No shadows, no reflections messing with how the sensors see the targets. And the area around the car needs to be clear. No shiny toolboxes, no reflective surfaces, no distracting patterns on walls behind the targets. It's got to be visually clean.
They told a story about an OEM training session, didn't they? Yeah, that really drove this home.
They did. Experienced dealership techs, guys who work on these cars daily, were failing the initial aiming tests. Why?
The floor wasn't level.
Often, yeah. They just picked a bay without checking if it was perfectly level. It shows how critical that one factor is, and that even dealerships can get it wrong if they're not super careful.
So yeah, a standard parking lot. Even if it looks flat, definitely out.
Completely out. Too many variables, uneven surfaces, changing light, other cars, background clutter. You just can't guarantee accuracy. iCar used the term pristine, almost hospital-like. That's the kind of environment you need.
And it's not just the floor levelness, is it? Snap-on mentioned needing enough space to
Correct. You need enough room to position the car and the calibration equipment exactly where the manufacturer says they need to go. Specific distances, specific angles.
Right? No obstructions.
No obstructions. Plus, good consistent lighting is key, so the cameras and sensors can clearly see the targets. And you've got to eliminate distractions nearby, like other calibration boards stored in the corner, or reflections from windows. Sometimes shops have to black out windows.
Wow, okay. Huge focus on the environment. Now, what about the car itself? What needs checking before you even start calibrating?
Right, the vehicle prep. Snap-on highlighted a few crucial things. First, you have to find the vehicle's true center line, that imaginary line straight down the middle.
Okay.
And maybe even more critical, especially after a collision, do a wheel alignment.
Before ADS calibration.
Absolutely, because a crash can easily knock out the thrust angle, remember? The direction the back wheels are pushing. If that's off, all your sensor aiming will be off too.
Makes sense. Foundational alignment first.
Yeah. Exactly. And simpler stuff too, but just as vital, make sure the windshield is spotless. Radar covers too. No dirt, bugs, even streaks. Anything blocking the sensor's view is bad news.
And the golden rule seems to be read the manual.
Always. Read the OEM-specific calibration procedures before starting. They dictate everything. The environment, the targets, the tools, the exact steps. There are no shortcuts that work reliably.
Speaking of targets and tools. ISAR shared that pretty shocking comparison. OEM versus aftermarket equipment. Tell us about that again.
Yeah, that was a real eye-opener. They tested two identical cars, calibrated one using the proper OEM gear, the stuff the factory uses.
Okay.
Tested its automatic emergency braking, worked perfectly, stopped the car safely, no driver input.
Good.
Then they took the same car, recalibrated it using a common aftermarket scan tool and targets. Repeated the exact same braking test.
Yes.
System completely failed, didn't even try to brake. Car crashed right into the obstacle. The only difference was the calibration equipment.
That is stark laughter. That really highlights the safety risks.
It really does. Use the wrong tools, and the safety system you're relying on might just not be there.
But didn't the ICAR discussion also mention that some OEMs are starting to approve certain aftermarket tools?
Yes, that's an important point. It's evolving. Initially, it was pretty much OEM tools only, but now some manufacturers, they mentioned Honda, Acura, Rivian, Lucid, Nissan, Kia as examples, are testing specific aftermarket systems and saying, okay, this particular tool is validated for use on these specific models.
So some aftermarket options are okay, but only if the car maker explicitly approves them for that car.
Precisely. You cannot assume that because a tool works on a Honda, it's fine for a Ford or Toyota. It has to be specifically tested and endorsed by the OEM for the exact vehicle you're working on. Big caveat there.
And sometimes it's not even about buying a target. You might end up to make one. That sounds odd.
It does, but yeah, some OEM procedures might require creating a custom target to exact specification, size, pattern, reflectivity that you can't just buy. And even with printable targets, like some used by Toyota, they mention super strict rules, specific printers, specific ink, specific paper, to ensure the printout is the exact size and scale needed. Tiny errors matter.
Wow. And sticking with tools, ICAR also had that story about a shop using the wrong type of calibration method, damaging a camera.
Right, another cautionary tale. This shop used an aftermarket tool to try static calibration, with targets, car stationary.
Okay.
But the OEM procedure for that specific car system was dynamic only, meaning you had to drive the car in a specific way to calibrate it. No static option.
So they forced it.
They tried to force a static calibration with the wrong tool, and it ended up damaging the camera. Costly mistake, completely avoidable by following the procedure.
And it's not just tools, right? Using aftermarket parts like windshields can cause issues too.
Yep, they cited a case with a Honda. An aftermarket windshield was installed and the camera mounted to it started overheating and failed.
Just from the glass.
Apparently so. It reinforces why using OEM parts is often recommended, especially for components directly linked to ADAS sensors. They're designed to work together.
Okay, we've covered the environment, the prep, the tools. What about the sensors themselves? How they're physically mounted? IKEA really emphasized mounting locations. Why so critical?
This is another area where tiny physical errors have big safety implications. Think about blind spot monitors, usually in the rear corners.
Yeah.
Their mounting angle is absolutely critical. If that sensor is off by just, say, 2 or 3 degrees from the spec.
Doesn't sound like much.
Again, no. But it can mean the radar beam is pointing slightly too high, too low, too far in, too far out. It might fail to detect a car right next to you or maybe give false alarms.
And they had a real-world crash example linked to this, didn't they?
They did. Someone had repairs done to a rear quarter panel. Shop said they did the calibrations, but the blind spot monitor wasn't working right.
What was the issue?
Turned out the replacement quarter panel wasn't stamped perfectly. Just a tiny imperfection in its shape subtly changed the angle the blind spot sensor was mounted at.
And that caused the problem.
Led to the system giving inaccurate info, indicating it was clear to change lanes when it wasn't. Contributed to a collision. Shows how deep these issues can go.
And some manufacturers actually have checks for this before calibration, an angle inspection.
Yes, exactly. Some OEMs require an angle installation inspection, using special digital gauges to measure the sensor's actual mounted angle horizontal, vertical against the specs.
Before you even connect the scan tool.
Right. It's about verifying the physical foundation is correct first. Identifying this need early in the repair plan is key because it might be an extra step, maybe not included in a standard labor estimate.
And even the brackets holding the sensors have specs.
Oh, yeah. Specific torque values for bolts, sometimes specific repair procedures just for the bracket if it's damaged. It all has to be right.
Okay, so let's say the environment's perfect. Prep's done, tools are right, mounting is verified, calibration procedures followed. Then, are we done?
Almost, but not quite. iCar was very clear. Post-calibration testing is essential. A final step.
Meeting a test drive.
Often, yes. A test drive, or sometimes OEMs call it a drive cycle or an action test. It's crucial to let the ADAS systems fully activate under real driving conditions and verify they're actually working properly.
Making sure it works on the road, not just in the bay.
Exactly. It's about achieving the necessary set conditions for the system to confirm its calibration and function.
What sort of set conditions are we talking about?
It really varies. For a blind spot monitor, maybe it only wakes up above, say, 30 or 35 miles per hour.
Right.
Other systems might need you to drive a certain distance or for a set time. Maybe specific maneuvers, drive straight for a bit, make some turns, sometimes even figure eights.
Figure eights, really?
Yeah, they mentioned one case after a windshield replacement needing a specific low-speed figure eight pattern to get the compass calibrated correctly.
Wow.
Where'd you find this info?
Usually in the owner's manual or the detailed OEM service info. It tells you what needs to happen during the test drive to confirm everything's okay.
Okay, that's thorough. Now, iCar also mentioned something really weird, dummy sensors. What was that about?
Yeah, that was a strange one. Shows the kind of curveballs techs can face. Apparently, at least one manufacturer used these dummy sensors for blind spot monitors on some cars.
Dummy meaning fake.
Essentially, yeah. Looked like a real sensor from the outside, but it was just an empty plastic housing. A placeholder, maybe for higher trim levels or future upgrades.
Okay, weird, but all right. So what was the problem?
The problem came when a shop was repairing collision damage. They saw what looked like a damaged sensor, ordered a replacement, but they ordered a real functioning sensor, not knowing the original was a dummy.
Oh.
Oh, he's right. They installed the live sensor. The car's computer system detected it and went into this unrecoverable conversion mode, basically expecting the whole upgraded system wiring and software, which wasn't there. Big headache.
How could they even tell it was a dummy?
That was a tricky part. VIN data wasn't always specific enough, and if the dummy housing itself was damaged, any dummy marking on it might have been destroyed or missed. Just another complexity.
Okay, wild. So let's just circle back quickly to the tools. Snap-on and that Artel tool Motor Age mentioned, the takeaway is you need the right gear, right?
Absolutely. Snap-on stressed that investing in equipment that meets OEM procedures is fundamental for precise, reliable calibrations. It's how shops become specialists.
In the Artel tool.
Motor Age highlighted the Autel MS909CV specifically for its ability to handle static ADAS on medium and heavy-duty trucks, supporting all the right communication protocols.
And it's not just the main scan tool, is it?
No. A comprehensive kit includes more battery testers, proper test leads, a multimeter for electrical checks, and the best practices they showed with the Autel. Always do a pre-scan for existing faults, double-check glass installations, and always do that post-calibration road test.
Yeah, both sources really hammered home the need for scan tools with broad ADS coverage and always checking the official service info.
Absolutely non-negotiable. You need a tool that can actually perform the calibration for the specific vehicle, and you must follow the manufacturer's step-by-step guide to ensure that car is safe when it leaves the shop.
So, Wrapping this up is just abundantly clear that ADS calibration is way more complex, way more safety critical than most people probably realize. It's not like just updating software on your phone. It's this intricate physical and electronic alignment, needs real expertise, the right environment, the right tools.
That's the absolute core message. It demands a meticulous approach. You have to follow the OEM procedures to the letter. Use the right gear. Control the environment. Prep the vehicle properly. Be skeptical of shortcuts. And always do that final verification test drive.
This deep dive, I think it really gives a solid foundation for understanding why this matters so much in modern cars. It's not just about convenience features. It's about safety systems working exactly as designed.
Precisely. Protecting drivers, passengers, everyone on the road.
Which brings us to maybe a final thought for you, listening. You know, with more and more cars having these ADS features, how does understanding all these calibration details, these nuances, maybe change your expectations when your car needs repair or maintenance?
Yeah, what questions does this raise? For you as a car owner, or even for the auto industry as a whole, as this tech becomes standard, definitely something to mull over.
And if you do have specific questions, maybe about your own car or a repair situation,
Yeah, good point. Resources like iCar's Ask iCar service could be helpful, or digging into the official service information from your car's manufacturer is always a good bet.
yeah.
And that's it for this episode. Thanks for tuning in to Shop Talk by Shopofficer. If you found this helpful, share it with a fellow mechanic or shop owner and follow for more real-world advice. Want to take your shop digital? Visit shopofficer.com to get started for free. Until next time, keep wrenching smarter.
1, 2,